Capacitance of transmission lines, problem-solving illustrations. Let's have our first illustration. So there is the single-phase transmission line. Binigyan niya tayo ng 24012-strand copper conductor as the detail of that conductor. And then with 5 feet spacing between conductor centers, the length of the line is 20 miles. We are now asked to have the line-to-line capacitance. So it's a single phase, so line-to-line capacitance and line-to-line admittance. Since this is single phase, if you may recall, we also have that capacitance to neutral, equation. But in this case, we are just simply asked to get the line-to-line capacitance, Then, if the line voltage is 20 kV, determine the reactive power that is supplied by the capacitance, So, since this is a single-phase line and line-to-line capacitance is being asked, so these are the pertinent equations, So, so let's start off with CXY. It's pi ln of t over r. And please take note that is in farad per meter. So now, let's have D as 5 feet and our R as what? So that's the question, no? I think it is not stated there. It's not given in our problem statement. Now, where do we get R? It's simply from the table of conductor characteristics, So you just have to locate the 4012 strand. I think that's the first page of the table I gave you, the copy of the table, So you may want to pause this video first, and then check your table of conductor characteristics, So having located that detail 4012 strand, it's copper, Iba pa kasi yung ACSR details. And you have to get the outside diameter. So from the table, you get the outside diameter for the 4012 40 meaning 12 strand conductor, So meaning your outside diameter is 0.552 inches or inch, 0.552 inch. So since we have the R already, so I think we can just plug this in, So we just have we don't want to forget, to divide, of course, this into 2 because the diameter, the given is diameter, and we are looking for R, And also, since this is in inches, in our spacing is in feet, so we might have to, of course, convert from inches to feet. Therefore, your capacitance, which is line to line, is simply plugging in all those values, and then multiplied to 1,609. That is to convert the meter to mile, kasi we are asked what I think yes, we are asked to get the line-to-line capacitance. So it's farad per meter yung default unit for CXY, and the given line length is miles, 20 miles, so that is in miles. So we have to convert meter to miles, So we'll have CXY of 1.663 to the negative 7th farad. So that's our line-to-line capacitance. And so next is the line-to-line admittance. So that's your Y Okay, so simply omega xy, cxy. So our assumption, of course, no, actually it's not assumption, given pala siya na 60 hertz. Okay, and then plug in cxy. Okay, we have 6.269 times 10 to the negative 5 s. Okay, for our admittance. For letter B, we are asked to get the reactive power supplied by the capacitance in kVAR. So, given your QC here, so again, plug lang natin yung Y, the admittance, and the given 20 kilovolt line voltage, and then we get QC. Okay? Okay. So that's for our first illustration of a single phase line. Now, if we will be asked of the capacitance to neutral, okay? So since meron ka ng y here, so you simply get Cn simply by multiplying to 2 yung cxy. Okay? O kaya naman, start from the equation Cxn is equal to 2 pi e over ln of d over r. Okay? Okay, so we'll have the second illustration. So determine the capacitance to neutral in microfarad per kilometer. You always have to take note of that, no? So especially if it's specifically stated na you get this and that in terms of kilometers, in terms of miles. Kasi nga, the default unit of our capacitance is in farad per meter. Okay? So we have here a three-phase line. Again, there is a specific conductor named cardinal, ACSR here, equilaterally spaced. So from the equilaterally spaced thing there, we know that this is a three-phase line with equal phase spacing. Okay? So from there pa lang, we know now among those those various formula, we know now what to use. Okay? So equilaterally spaced 20 feet apart. What is the charging current of the line at 60 hertz and 100 kilovolts line to line? Okay? Okay. So, yan yung gagamitin natin. So, let's start off with Cn. Okay? So, it's 2 pi permittivity over ln of d over r. Okay? So, since three-phase, ang inanap is capacitance to neutral. So, that is what we're gonna use, Cn. Okay? So, one by one, we have our D already, but again, yung R, nasan ka na naman? Where are you? R. From the table, so we just have to locate the cardinal ACSR. Okay? This is an ACSR, no? Hindi lang siya pure copper. So, I think this is the succeeding page in our table, no? Now, in inductance, we're always getting the GMR, something like that, no? From the table. At this point, our R here is the outside diameter. Outside diameter siya. So, in this case, for cardinal, it's 1.196 inches. Okay? So, what else do we need? Ayan, convert lang natin this outside diameter becomes the radius, tapos convert to feet, no? Because the distance of the conductors are in feet. Okay? So, your Cn will simply be plug in everything here. So, we have ln of 20 over that r. Okay? However, we need the microfarad per kilometer. Per kilometer. Okay? So, again, yung meter natin, we just have to inject 1,000 para maging per kilometer. Okay? So, our CN is given as microfarad per kilometer. Okay, is it clear? What else do we need? The charging current, okay, is simply like that. Okay, so again, this is capacitance to neutral. Okay, so what is the charging current of the line? So walang sinabi, no? Actually, we can have the we can take the capacitance to neutral quantity, or I mean unit, okay, in order to get the charging. So we are assuming that we will also get the charging to neutral then. Okay, so since what's available is Cn, or the neutral capacitance, so yung voltage natin will be line to neutral also. Okay, so simply that's omega, and then our capacitance to neutral, and our the given line-to-line voltage 100 kV, of course, divide by square root of 3 to make it per phase. Okay, so the charging here, current is ampere per kilometer. Okay,